case of theory of pharmaceutical suspensions, uh, the theory of sedimentation, the rate of sedimentation of particles can be expressed by the Stokes law using the following formula that rate of sedimentation V uh, equals to d square rho s minus rho 0 into G divided by 18 eta or 18n, where d is the diameter of the particles, CGS unit centimeter. Uh, Rho s is the density of the dispersed phase, CGS unit gram per centimeter cube. Rho 0, density of the dispersion medium or continuous phase. Uh, Unit is gram per centimeter cube. Eta or n, viscosity of the dispersion medium. CGS unit is Boyce. G is the acceleration due to gravity, which is 980.7 centimeter per second square. Now, this Stokes law is applicable in the following conditions. Number one, particles should be spherical, but in the suspensions, particles are largely irregular. Number two, particles should settle freely and independently. Such conditions can be satisfied by dilute suspensions. That means 0.5 to 2% solids per 100 ml. But most of the suspensions contain dispersed solids in concentrations of 5 to 10% or higher. In these suspensions, solids exhibits hindered settling. Therefore, particles interfere the free settling of other particles. So, Stokes law cannot be applied for this type of suspensions. Okay. Stokes law is applicable to the deflocculated systems wherein the particles settles independently. However, the law is useful in qualitatively sense in fixing factors which can be utilized in formulations of suspensions. They are like particle size, viscosity of the medium, density of the medium. So in case of particle size, if the particle size is reduced to half of its original size, the rate of sedimentation decreases by a factor of 4. Smaller particles facilitates rapid absorption. And number 2, viscosity of the medium. The viscosity of suspension should be optimum. Okay, it is interfere the higher higher the viscosity, lower the rate of sedimentation, and lower the viscosity, higher the sedimentation rate. So selection of higher viscosity has several advantages and disadvantages. The advantages of higher viscosity are as follows. Like higher viscosity enhances the physical stability because of sedimentation is retarded. Higher viscosity inhibits the crystal growth because movement of particles is diminished. Number 3, higher viscosity prevents the transformation of metastable crystals to stable crystals. Okay, and the disadvantages of high viscosity are as follows. Like high viscosity hinders the redispersibility of the sediment, and the high viscosity retards the absorption of drugs from the suspension. Next, the high viscosity creates a problem in the handling of materials during manufacture, like pouring to one equipment to another equipment or a bottle to another bottle. And we have already discussed that suspension must redisperse redispersible by shaking, mechanical shaking. So in case of higher viscosity, uh, the, uh, it hinders the redispersibility of sediment, of that sediment. and drug absorption is hampered here for higher viscosity because higher viscosity deters the absorption of drug from the suspensions. So the advantages are high viscosity enhances the physical stability, inhibits the crystal growth, and prevents the transformation of metastable crystal to stable crystals. And the disadvantages are redispersibility problem, absorption of the drugs, that is the problem, and handling of materials, the big problem. So I already told the particle size, viscosity of the medium, and the next is next factor is density of the medium. So density of solids used in pharmacy are generally from 1.5 to 2 gram per cc. 2.0 1.5 to 2.0 gram per cc. According to the equation, if the density of the medium is equal to the density of the solids, listen carefully, density of the medium is equal to the density of the solids, the rate of settling becomes zero. Okay, in general, density of the medium is about 1.0 gram per cc on account of aqueous phase, and therefore there is a need to increase the density of the medium, so that case difference in densities will be minimal. Okay, the density of the medium can be increased by including the ingredients such as polyvinyl pyrrolidone, PBP, sugars such as sorbitol or dextrose, polyethylene glycols, glycerins, etc. For increasing the density of the medium, we can use these things like PBP, sugar derivatives like sorbitols, sugar we can use sugar syrups, or sugar derivatives like sorbitol and dextrose, PEG, that means polyethylene glycols, glycerin, etc. However, these should be used in high concentrations, but improvement in density will be less. Hence, this is not a viable factor to decrease the settling factor. Okay. So theory of sedimentation already covered. Here the sedimentation parameters. Three important parameters are considered, like sedimentation volume, that is denoted by F, the ultimate volume of sediment, height, sedimentation volume or height. Okay, these are same things. It is denoted by H, capital H, or for flocculation suspension. So F, that means sedimentation volume or height, equals to VU divided by V0. VU is the final or ultimate volume of sediment, and V0, that is original volume of suspension before settling. Okay. Also denote this equation is also represent like this, that F, that means sedimentation volume, equals to HU divided by HO, where H, that means the height, HU is representing the final or ultimate height of sediment, and HO is the original height of suspensions before settling the sedimentation.